inshallah today we'll be carrying on with our replacement presentation. You guys can start, and inshallah after this presentation we'll be discussing about what to do next. Okay?
Alright.
Okay, guys, which group will go first?
Oh, okay. Uh, Sorry, sir. There are like 4 more people are not here yet, actually.
Okay, no problem. We will be waiting.
Okay. Thank you for your patience, sir.
Nofal, is the next week holiday, right? Midterm break for you guys. True?
Next week,
When is your midterm break?
uh, we don't have any other break, actually.
Okay.
The last break we had was the Chinese New Year one.
I see. Okay.
Yes. Sir, are you there?
Yes.
Okay, sorry for the delay. Uh, everyone is here now, so I think we can start our presentation for this one, for our part. Shall I start?
Yes, please.
Okay. Assalamualaikum and good evening to everyone. I'm Nofl Hafiz in Group 1. So today we'll be learning about database system, design, implementation, and management. So today is going to be chapter 5, normalization of database tables. Okay, I will I will I will pass my voice to Shiva.
Uh, okay. Okay. Objective. In this chapter, you will learn firstly what normalization is and what role it play in the database design process. I will explain page 3 about the normal form, one normal form, two normal form, three normal form, and four normal form. Uh, Number 3, how normal form can be transformed from lower normal form to higher normal form. Number 4, that normalization and ER modeling are used concurrently to produce a good database design. That some situation require denormalization to generate information efficiently. Next, Nova. Okay, firstly, what normalization? Normalization is a database design technique that reduce data redundancy and eliminate undesirable characteristic like insertion, update, and uh, deletion anomalies. Uh, normalizes, Normalization is process for evaluating and correcting table structure to minimize data redundancies. Example, reduce data anomalies. Work through a series of steps called normal form. And normal form like a rule. The process what doing step by step. First normal form, one normal form is for to eliminate and repeating group individual tables. Create a separate table for each set of related data, and then identify each set of related data with a primary key data. And then second normal form. Second normal form is for create separate table for set of value that apply to multiple record. And then third normal form. Third normal form is for eliminate field that do not repeat on the K. Next. Normalization. If a rule or one normal form, if observe the database that say to be in first normal form, if the first three rules are observed, the database considered to be in third normal form. Uh, and then the normalization. The normalization is process of adding pre-computed redundant data to an otherwise normalized relational database to improve performance of database. Different of the normalization and normalization is uh, The normalization in to reduce data redundancy and inconsistency. But the normalization to achieve the faster execution of queries through introducing redundancy. And then I will pass to Venkat.
Uh,
Wait. For more business, database design purpose three normal form is a height as need is no normalization in normalization. If the rule are not followed, that could occur such as redundant data and inconsistent dependencies. Dependencies. Okay. Next. Sorry.
okay. Thank you, Shiva. Before we go to the next, can you guys nagsonofa again?
Yes.
So, okay. Before we continue, I would like to elaborate a little bit more
Okay.
on this slide. Okay. Shiva is okay. So normalization is basically like we are trying to simplify a set of data like in this like in the table like in the table like there's a bunch of things inside these tables. There's a bunch of things, and this is like the main category. I would say category, but uh, let's say there are a bunch of things in here, but we want to like minimize this to reduce, like it says here, reduce data anomalies. So you might be asking, what is data anomalies? So we have found this on the internet. So let's say it says here that normalization is a process of splitting relation into well-structured relation for a clean data model. This allow user to avoid redundancies across tables and their management. Wait, maybe you cannot see her. Let's zoom in. There we go. There we go. Oh. While avoiding anomalies at update, deletion, and insertion. Basically, like there's a bunch. We want to clean the data more in model inside a. We want to clean the data, but also reducing the chances of getting any not getting any errors, like getting more like cluttered in the table, and also helps like also helps like updates, deletion, insertion, and so an updated anomaly is a data inconsistency. It's a data inconsistencies that result from a data redundancies and partial update. For example, each employee in a company has a department associated with them, as well as student group they are participate in. So we can see here uh, these well structured data. Like so here we have ID, like a specific ID for each employee, and we have names here. We have a department, which course are they taking, and student, and also student group they are in. So the uniqueness is this employee ID here. This is the unique. We will call this one like the very unique entity here. Okay, so and then let's continue. Okay. Oh no. Where's my? Okay. Okay. So in a way we can do this normalization. It's like there are so far in this slide there's only three. There's three, and we need these three we need to know. So these three, the first normal form, second normal form, third normal form, these will help avoid avoid data anomalies, avoid data Actually here, actually, just it's three steps actually. Yeah, three steps. This is like first step, second step, third step. Okay, and then here. So I want to speak about this one, this part. So highest level of normalization is not always most desirable. So later we'll know what this phrase means later in the slide. And also here, denormalization produce a lower normal form. Price pay is increased performance is a greater than data redundancies. So we know, and also here, two normal form is better than one normal form. Three normal form is also better than two. Okay, basically like, so there's three levels, right? One normal form, two normal form, three normal form. So up here, we know there is like a more chance to get data redundancies. But if we go lower, more lower, is down here is less likely to get data redundancies. So the lower we go, the more simplified the data become, and the more less of the data redundancies we'll get. I think that's all I can say for this slide. I will pass this to Venkat, I guess. Yeah.
Thank you, thank you. Okay, pass to the next.
Thank you, Nafal and Shira. I'll continue. The need for normalization. Why do we need to do normalization? Here we have an example of a report, which is a company that manages building projects. And in this report, you'd see that it charges its client by billing hours spent on each contract, and hourly billing rate is dependent on employee's position. Just keeping note that hourly billing rate is dependent on employee's position. That is really important. You'll see later on. And lastly, is periodically report is generated that contains information such as display in table 5.1, which we will see now. Next slide. This is the entity that will be in the report, and it's also an attribute. First, we have the project, which is project number and project name. And the next one is employee and employee number and employee name, which you will see in the report and the table. Next slide. This is the sample report that I was talking about. As you can see here, there's project number, project name, employee number and employee name that we've seen before. Okay, and the charge hour is based on job class, which I said before that you should take note of. It's dependent on job class. Now let's take a look at the table. From the same report, we got a table. Next slide. And this is the table. As you can see in this table, it's not really good, is it? It's not a perfect structured data. There's spaces in the table. It's not fully written in. Yes. Next slide. So also in this table, we don't have a primary key yet. And in a table, we know that we should have a primary key. Okay, next slide. As I said before, the structure of data in that figure, in that table, doesn't handle data very well, does it? The structure of the table appears to work, and the report was generated with ease. It's not simplified yet, that's why. The report may yield different results depending on what data anomaly has occurred. There's a lot of data anomaly in that data, as we saw. For example, the spaces in the data. And we don't have a primary key as well. And we don't know the relationship, which is the dependencies of the data in there. And a relational database environment suited to help designer avoid data integrity. That is normalization. That is the whole point of normalization. Next slide. Okay, so in the normalization process, each table represents a single subject. And no data item will be unnecessarily stored in more than one table. which we will do in this normalization process. We will simplify it, and we will make sure there's no more anomalies, and we reduce data redundancies. And all attributes in the table should be dependent on the primary key. If not, it is we're doing the normalization process wrong. And each table is void of insertion, update, and deletion anomalies. And what does that mean? And we will see.
Nice. So, wait, is it this one? Is it? Oh no. Is it this one? Oh no. Maybe it's this one. Is it? Is it this one? I forgot.
Wait, I can't see. No, it's not this.
It's not this one.
Oh, it is. Go up, go up.
Is it this? Oh, this one. Is it? 2 times.
As you can see, a deletion anomaly is the unintended loss of data due to deletion of other data. And as you can see, this results in database inconsistency, and we do not want that in our table. And an example is how combining information that does not really belong together into one table can cause problems. And an insertion anomaly is the inability to add data to the database due to the absence of other data. Let's just say a null value is not allowed for one attribute. And if a new if a new data should be added in, but since that attribute is null values are not allowed, you can't add it in. So this will cause a new anomaly, and it also results in database inconsistency. So as you can see, update, deletion, and insertion anomalies are very undesirable in any database. So we're going to do normalization to avoid all of these anomalies. And this is why normalization is very important. Next slide.
Cool.
Okay, these are the normal forms that we have. We have first normal form. Its characteristics is a stable format. There's no repeating groups, and the primary key is identified. That's the most main important part about first normal form. The primary key is identified. In second normal form, it's basically everything of first normal form and extra no partial dependencies. We'll look at what is partial dependencies later on. And in third normal form is everything of second normal form and extra no transitive dependencies. In Boy's court normal form, which is Bcnf, every determinant is a candidate key. We'll also see what's a candidate key, which is later on. And in fourth normal form, which is basically everything of 3NF and no independent multivalued dependencies.
Next.
Yes, next. So an objective of normalization is to ensure that all of the tables from a basic table, and we should make it at least 3NF. We have to go through 1NF, 2NF, and 3NF, at least 3NF. Although higher forms are not likely to be encountered in business environment, because it's too simplified and we do not have the bigger picture. Normalization works one relation at a time. You have to go step by step, and you can't skip from first NF to 3NF instantly. No, this doesn't work that way. You have to go by process. And it will progressively break table into new set of relations and based on identified dependencies. We will have to identify the dependencies and make new table based on it.
Oh. Yeah. So about this part, the higher form is not likely to be encountered in business environment. So what does this mean? Like, let's say you're in a meeting, right? You're in a meeting, your business meeting, and the boss wants to know how's the all the employees are doing. But he's a simple man, simple businessman, and he does not know about all this data. He wants to know at least a bigger picture of the data. But we want, but we usually want to simplify the data, the table as simplified as possible, so to reduce these redundancies. But since it's too simplified, so the boss will not very understand how this and that works, like what does this the table even mean. So and also, so you can see first normal form is, it will have too much information. If we look in this one, something like this, hold on, I think it's down here. Yeah, something like this. So you will see, if you even look at this, this is too much stuff to even see at first glance. So first normal form is too much. Maybe two
Naufal,
yeah.
Naufal, can you just give me 3 minutes? Can you stop for 3 minutes?
Sure. Okay.
Okay, 3 minutes and I will be back.
Okay.
Doktor bagaimana?
Shiva tak dengar tadi. Dah habis dah kelas.
Kelas dah habis, Syirah. Syirah leave.
Dah habis tau.
Tak, Syira dengar je tau doktor kata dia nak pergi lain. Kau tak payah tau cakap dah habis.
Tak, memang dah habis.
Bengkat, I tak nak kawan you 10 tahun tau. Serius lah dah habis. Dia payah tipu lah.
Serius dah habis.
Korang apa yang jadi? Apa ni?
Tak, doktor keluar jap kan 3 minit.
Betul.
Mana?
Nampaknya macam 1 pagi je habis ni.
1 pagi aku tidur dulu. Kau tutup lah.
Syira tidur dulu lah. Dah habis dah present, bye.
Habis ke belum? Okey, kita boleh bersurai sekarang. Terima kasih semua.
Banyak lah.
Oh. Oops. Pause. Oh. Okay. Okay, I'll search that. Okay. Where was I? Okay, here. So as you know, first normal form is too much information. Second normal form is good information needed, and the third normal form is very simplified. So maybe second normal form is maybe good for presentation. Okay. Okay, next is
Okay. Functional dependency concepts. Remember when we saw those dependencies that I was talking about? Okay, here will be explained. What is functional dependencies? Okay, here we have an example concept. Attribute B is fully functional dependent on attribute A if each value of A determines one and one only value of B. I know it seems confusing, but here's an example. Project number is functionally determines project name. What does this mean? This means project name depends on project number. If there is no project number, you wouldn't know project name. Just think of it as like that. Okay, in this case, which is here, project number is known as the determinant attribute. Basically, project number determines project name, its value, and the attribute project name is known as a dependent attribute. If you can grasp this concept, you'll understand what is functional dependency. So here is a more generalized definition. Attribute A determines attribute B. I give you an example, which is project number determines a project name. That means B is functionally dependent on A. which is project number is functionally dependent on project name. If you guys can understand, it's really good. If all of the rows in the table that agree in a value for attribute A also agree in value for attribute B, which means that if project number is true, then project name should be true as well. And so now we look at composite key, a fully functional dependency. But if attribute, okay, let's look at what is composite key first. Composite key is a combination of two or more columns in a table that can be uniquely identify each row in the table. And uniqueness is only guaranteed when the columns are combined, which is the attribute. Okay, so if attribute B is functionally dependent on a composite key A, let's say composite key A means key A is, let's say the attribute is combined with another attribute. So key A is two attributes combined. It's not just one, okay? Keep that in mind. Every time you see a composite, it means something is combined with something. But not any subset of the composite key. The attribute B is fully functionally dependent on A. That it's fully functional dependency. As you can see below, attribute A plus attribute C equals to attribute B. That is attribute A and attribute C combined is a composite key. And attribute B will become a fully functional dependency. And you have identified its dependency. Next slide. Okay, conversion to first normal form. How do we convert a normal table to first NF? First, repeating group. A group of multiple entries of same type exists for single key attribute occurrence. Sorry. Okay, this is its condition. You need to know all of these conditions to convert one normal table to a first normal form. And a repeating group is a really important key part for first normal form. You will see this later on. Relation table must not contain repeating groups, which I said earlier. And a normalizing table structure will reduce data redundancies, which is really important. And normalization is a three-step procedure, which is 1NF, 2NF, and 3NF. Okay. Step 1, we need to eliminate the repeating group, as we said before, which is repeating nulls. Each repeating group attribute contains an appropriate data value. We need to make sure that each of the spaces are filled in, which you will see later as well. Step 2 is to identify the primary key, which has been said earlier as well. Without a primary key, we cannot finish the first normal form. What is primary key? You must uniquely identify attribute value, that is primary key. And a new key must be composed from the table. And step 3, we need to identify all dependencies to go to the next step, which is second normal form. With all these dependencies, we are only allowed to do second normal form. Next step. Okay, this is an example table of first normal form. And all of these attributes was from the report before and the table before that we saw. As you can see, there's no more empty spaces. All the spaces are filled in. But because of the spaces filled in, it causes data redundancy and repetition of data. That's what it means. As you can see, there's a lot of same numbers, same values are repeated, and that's not a good table, is it? It's very messy to look at. It's full. It's too full. You don't really know what you're getting at the first glance. And in the bottom, as you can see, it's also dependencies. But you can see this project number and employee number. You get project name, employee name, job class, charge hour. I'm sorry, it's spelled wrong, but it's okay. As you can see, project name, employee name, job class, charge hour is dependent on project number and employee number. So project number and employee number is our primary key. And these are formed, this 1, 2, 3, and form, as you can see, is the dependencies are formed for us to allow us to go to next normal forms, which is second normal form and third normal form, because we need to identify the dependencies before we move on. Okay, next table. What we saw just now was not quite the dependency diagram, but it's good enough. That is basically a simplified version, like a note to ourselves. Can you go back to the last slide? Yes, this is basically what we wrote is as a simplified dependency. We can know what is dependent on what just from this thing. Okay, next slide. So the little note that we wrote, the dependency diagram, depicts all dependencies found within the given table structure, which is from that same table, we found out what depends on what, and we wrote it down. It's helpful in getting a bird's eye view of all the relationships among table attributes. Like I said, we know what is dependent on what. We can make new tables, simplify it, and it makes it less likely that you will overlook an important dependency, which is really important. Imagine if you overlook like what we said earlier, the charge hour is dependent on job class. If we overlook that, and then we could get an attribute completely wrong. We couldn't make a table, and we would fail in normal forms, in a higher level of normal forms. Next slide. Oh, okay. In this table, we can see the dependencies. It's shown in arrows. As you can see, the ones that is being underlined is the primary key. You should take note of that. And employee number. Okay. As you can see, project name is dependent on project number. Okay. And project name is also dependent on employee number. Employee name is dependent on employee number, and so on, as you can see by the arrows. But as I said earlier, charge hour is dependent on job class. And since it is not a primary key, it's a transitive dependency. And that is used for 3NF, which you'll see later on in the slides.
Next. Oh, okay. So the first normal form describes the tabular form in which all keys attributes are defined. There are no repeating groups in the table, and all attributes are dependent on primary key. So so what this means? Okay, what it says here, all attributes are defined. It means like it has been underlined that we saw here. Yeah, it has been underlined and identified. So we have we know which is the primary key, and then so there are no repeating groups in the table. So if yes, there are no repeating groups in the table. All attributes are dependent on the primary key. All relation table satisfy one normal form requirements that we saw above, around here. Yeah, here. Relation table must not contain a repeating groups. Normalization structure reduce data, and normalize 3-step procedure. And also some tables contain a partial dependencies, which is dependencies based on a part of a primary key and should be used with caution. So this is also the reason why to go to the next step, which is the 2NF. Some tables may contain it still has dependencies, but not less now. So yeah, this is also the reason why to continue to the second normal phase and the third normal phase and so on. Right, that's all from us for today.
That's it. That's all for us. We will pass this to the next group.
Okay, Assalamualaikum and good evening to Dr. Abdullah and everyone. First of all, my name is Muhammad Shukri bin Jong. I'm from Group 2. Today, so next step. Shakila Ahmed. Next. Okay, this is my group member. The first one is Muhammad Haji Kafif bin Zaha. The second one is me. The third one is Nurul Tasnim binti Baharuddin. The fourth one is Nurul Shakira binti Sabri. And the last one is Nur Zuria Nabila binti Zulkifli. Okay, so this is the continue of what group 1 has been present today. So we will continue on to second number form. Okay, this is a conversion from first number form to second number form. There's a two step in here. So the first step is write each key component on a separate line, which is we write each key component on separate line, then we write original key on that line. Next is each component will become key in the table. And the next step is assign corresponding depend attributes, which is determine those attributes that are dependent on other attributes. At this point, most anomalies have been eliminated. So next, okay, this is figure 5.4, which is second number form conversion result. So I will talk a bit about this. The first example, which is the simple table name. So as you can see here, the project name, the project name and project name has a difference between them, which is the project name is underlined and the project name is depend on project name. Okay, next slide. So this the continue of second normal form depend on the table is in second normal form. It is in one normal form and it includes partial dependencies, which is no attribute is dependent on only a portion of primary key, which is this type of feature must be in second normal form. Okay, next. Okay, this one is conversion from second normal form to third normal form. So there we have three steps here. So the first step is identify each new determinant for every transitive dependency. Write its determinant as primary key for new table. PK is primary key. Determinant, any attribute whose value determines other values within a row. Second step is identify the dependent attributes. Identify the attribute dependent on each determinant identified in step 1, which is identified in dependency. Name table to reflect its contents and function. Next. So this is the third step. Remove the dependent attribute from transitive dependencies. Eliminate all dependent attribute in transitive relationship from each of the tables. Draw new dependency diagram to show all tables defined in step 1, 2, 3. And the last one is check new tables as well as tables modified in step 3, which is each table has determinant and no table contains inappropriate dependencies. So this is the figure 5.5, which is third normal form conversion result. So this figure is also same like figure 5.4. So I will not talk about this because I already talked about this before. So next, I will pass this presentation to Nurul Tasnik Binti Baharudin. Oh, sorry. I know. So this is the last one part, or this is last part for me. A table is in third normal form, three normal form when both of the following are true. When it is in two normal form, it contains non-transitive dependencies, which is these two types of feature must consist in this three normal form table. Okay, so I will pass to Nurul.
Improving the design. Table structures clean up the eliminate initial partial and intransitive dependency. Normalization cannot by itself be relied on to make good designs. It is valuable because it helps eliminate data redundancies. Improving the design. Continue. Issues to address in order to produce a good normalized set of tables. Evaluate picky assignment, evaluate naming convention, refine attribute atomicity, identify new attribute, identify new relationships, refine primary keys as required for data granularity, maintain historical accuracy, evaluate using derived attributes. Figure 5.6 is the completed database. Surrogate key considerations. When primary key is considered to be unsuitable, designers use surrogate keys. Data entries in table 5.3 are inappropriate because they duplicate existing records. No violation of entity or referential integrity. Table 5.4 shows the duplicate entries in the job table. Higher level normal forms. Tables in 3 and F perform suitably in business transactional database. Higher order normal forms useful on occasion. Two special cases of 3 and F, voice code normal form and fourth normal form. So I will now hand over to my colleague Haziq.
By the way, thank you, Nurul, for speaking louder and changing the sleepy voice for everyone. Everyone was like talking and they were sleepy. So thank you for mixing things up. Carry on.
So we continue to the voice code normal form Bcnf. Every determinant in table is a candidate key, has same characteristic as primary key, but for some reason not chosen to be a primary key. When table contains only one candidate key, the 3NF and the Bcnf are equivalent. Bcnf can be violated only when table contains more than one candidate key. Next. Most designers consider the Bcnf as a special case of 3NF. Table is in 3NF when it is in 2NF and there are no transitive dependencies. Table can be in 3NF and fail to meet Bcnf. No partial dependencies, not thus in content transitive dependencies. A non-key attribute is the determinant of a key attribute. Next, figure 5.7, a table that is in 3NF but not in Bcnf, as you guys can see. Okay, next. So this is a sample data for Bcnf conversation. We had a 1, 2, 3, 4 column. First, student ID, staff ID, class code, and enroll grade. Next. The last but not least, decomposition to Bcnf. The first one is 3NF but not Bcnf. Second is 1NF. Okay, next. Okay, this is a video, so you guys can watch the video. Listen carefully.
Thank you.
Nggak ada suaranya.
Kira, Som, Kira. Betul.
What does that mean? Well, it's really quite simple. Each row in the table must be unique, and therefore there cannot be any duplicate rows in the table. So you can't have two different rows where all of the data contained within those rows is identical. And we'll give you an example in a minute. And each cell must only contain a single value. So you can't have a cell in a table that has a list of values in that cell. That's a no-no. And finally, each value should be non-divisible, which means that if you've got something in a cell, you can't break that down into further sensible parts. So let's have a look at an example of each of those. So each row must be unique. So let's have a look here. We've got a table of takeaway orders here, and we've got for each takeaway order, we've got a customer name and a customer order. So for instance, Bob Jones ordered here, he ordered burger, fries and Coke. Fred ordered nuggets, lemonade and fries, and then Bob also ordered burger, fries and Coke. Now that's fine, apart from we can't tell the difference between this row here and this row here. So we have no idea, for instance, which order was ordered first. No idea at all. So we need to change that because they need to be uniquely identifiable. And the way we do that, nice and simple, is we just add an order ID column. So here, order ID number 1, well, that was Bob Jones, and he ordered his favorites there. Order ID 2 was Fred's, and he ordered all those. And then the final order was Bob Jones, and he ordered his favorite order again there. So because we got these order ID, that row there is now no longer identical to that row there. There we go, good. So that's the first part of first normal form done. Second part, let's have a look. Each cell must only contain a single value. Well, yep, as you can see here, this cell here doesn't contain a single value. It contains 3 items: a burger, fries, and Coke. In fact, all of them do. So these ones here, in this area, the actual order ID, they all do. So that's no good. So what we need to do there is we need to move those into a separate table so that each row only has 1 item. Let's have a look. So it's going to look a bit like that. This table here has an order ID in one column and the item corresponding to that order ID there. So order ID 1 has a burger, order ID 1 also has fries, and order ID 1 also has a Coke in there. And as you can see, each item in this table now is uniform. Now, second normal form, not quite as much to it. All you need is there are no partial dependencies. Well, what does that mean? Well, what it means is, first of all, that the table must first be in first normal form. So you can't have a table that's in second normal form until you've gone through all those rules that we just did from the previous one from first normal form. It must do those first, and then we must have all non-prime attributes should be fully dependent on the candidate key, and it's fully dependent on the whole candidate key. Well, what does that mean? It sounds a bit complicated, but it's not. So let's have a look here. We've got a list here of students, so the student ID, the course ID that student is doing, and how much that course costs. So here, this student, they're doing course, so student 1 is doing course ID number 1, and that course costs 500. And student, so student ID 2 here, he's doing course 3, and it's 750, and student 3 is student 2 is doing course 3, and here student 3 is also doing course 3, and it's costing 750. Well, what's the problem with this table? And the problem is that the course fee has got nothing to do with the student ID. So the course fee is a set fee that only depends on the course ID. So this particular course, course 1, costs 500. Course 2 costs 1,000. Course 3 costs 750, and as you can see here, it doesn't matter whether it's student ID, student 2 is doing course 3 or student 3 is doing course 3. For either of those students, it costs 750 for each, and that's because the course fee has nothing to do with the student ID. Now, it's important here to note that the course fee is not dependent on the student ID, and the student ID forms part of this composite key here of student ID and course ID. So this is the composite key, but this bit is only dependent on that bit, and it's not dependent on that bit. And that's where you get this partial bit, because it's not dependent. It is dependent on this part of the composite key, but it's not dependent on this part of the composite key. So that's where we get the partial part of it. So what have we got to do to fix this? Well, nice and simple. All we do is we move this information to a separate table, just like that. So we have a table about course fees, and each course ID has a course fee attached to it. Course 1 is 500, course 2 is 1,000, etc. And the other table, we pretty much keep the same. But we don't need this extra course fee information. We just get rid of that column, and we only have the student ID and the corresponding course ID. So student 1 is doing course 1, student 1 is also doing course 2, student 2 is doing course 1 and course 3, etc., etc. So that is no partial dependency. It must be fully dependent on each of these parts of the composite key, if you've got one. Okay, so that's second normal form. Third normal form, no transitive dependency. So it's similar to the previous one, but we're not talking this time about the primary key or the composite key. We're talking about something else. So just like when you try to put something into second normal form, it had to already be in first normal form. Well, third normal form is the same idea. What you need to do is it needs to be in second normal form. But of course, that also means that therefore, if it needs to be in second normal form, it must also be in first normal form, because the two go back. So anything that's in third's got to be in second, and obviously anything that's in second's already got to be in first. So it needs to tick all those other boxes. It can't be duplicates, it can't be divisible, it can't be multiple values. It also can't have a partial dependency. So all of those. And then it must also do this third, this other item here, which is no transitive dependency. Again, sounds a bit weird, but all it means is that all fields must be only determinable by the primary or composite key, and you can't determine any of the fields by other keys in there. So what does that mean? Well, let me show you a nice simple example. Here we go. So here we've got a list of tournaments that I pulled from Wikipedia, and here it's there's the tournament name, and that's the year the tournament was in, and then we've got the winner of the tournament and the winner's date of birth. So this works well. It all fits through to first and second normal form, but there is a problem with this table, and the problem is that you can determine one of these keys by looking at another one of those keys. Can you see which one it is? Well, nice and simple. It's here. You can tell what the winner's date of birth is by going to the winner's name. So here you can go. You know that the winner's date of birth is this date of birth because that's his name. Okay, and he's got that name. So although it's not dependent on these bits here, you can't tell the winner's date of birth from the tournament name or the year. You can tell the winner's date of birth from the winner's name. Okay, so that's no good. So this information, as it stands, can't sit inside of the table. So what have we got to do? We've got to fix that, and you could do that by having a separate table of winners here. So for instance, here we've got the tournament name, the year, and the winner there, and we have a separate table that says, okay, Al Fredrickson, his date of birth is this, and we split the two. And this works because here the winner is dependent on the tournament name and the year, because that tournament happens every year, so you can't work out who the winner is just by the name of the tournament itself. And there are multiple tournaments in one year, which means you can't determine the winner just by looking at the year. You have to use both of the name of the tournament and the year in which it was held in order to work out who the winner is. So that fits perfectly. And then over here, again, the date of birth corresponds to that particular winner. There you go. Okay, good. So that is first, second, and third normal form. If you like that, then please subscribe to my channel.
That's all from our group. Thank you.
Okay, thank you guys so much. Is that all for all the groups, right?
Yeah, doctor.
I can't hear you clearly. So that was it for everyone, right? Hello. So you guys,
The, the
I
next
can't, I can't hear you, Muhammad.
can you repeat, Doctor? Please? Thank you.
I'm saying, is that all for the presentations? Is there any group left or any content left, or everyone has presented?
Oh. Yeah, Doctor.
There's one more group for
Yeah,
chapter 5.
yeah, carry on.
Assalamualaikum and good morning everyone. Today we're going to talk about chapter 5, normalization of database table. In my group we have Danish Fahan, Muhammad Syami, Razrin Rayu, Vicky and Nur Ain Fatihah. Next. Force normal form. 4NF is a normal form used in database normalization. It introduced by Ronald Fagin in 1977. 4NF is the next level of normalization after Boy's court normal form Bcnf, and it also has no multivalued dependency. 4NF is largely academic if tables conform to following two rules. The first rule is all attributes dependent on primary key independent of each other. If you don't have a primary key in your table, then such entity is called as a weak entity. And the second one is no row contains two or more multivalued facts about an entity. Next. Multivalued dependency. The first rule is a table should have at least 3 columns, not 4 or 5 columns, at least 3 columns. The second rule is for a dependency A to B for a single value of A, multiple value of B exists. And the last rule is in a relation of 3 attributes for a multivalued dependency A to B, then B and C should be independent of each other. Next. We are going to see the tables with multivalued dependencies. We are going to select the volunteers in 3 tables. I just remember the 3 rules of multivalued independence. The first rule is the multi-value dependency table that has at least 3 columns. So it meets rule number 1. The second rule is attribute A to be dependent on attribute B, and attribute B have to be multi-values. So you can see here every employee number is the same and organization code is different. So it can be say organization code is multi-valued. Hence, it also meets the second rule. Next, the third rules, attribute A and B have to be dependent, and attribute B and C have to be independent. You can see the organization code and the assignment number are different, and there is no duplication of data here. So this also meets the third rule in multivalued dependencies. Next slide. So now we are going to see a set of tables in 4NF. In 3NF, there are 4 tables, but in 4NF, there are 5 tables. It's because they are divided into small parts. These tables don't have a multivalued dependency, and all of these tables have their own primary key, and all attributes depend on that primary key. And the attributes independent of each other. For your information, if multivalued dependency means it should meet all the 3 rules, let's check out all the 3 rules here. Is that meet or not? Rule number 1 is meet in this table that at least have 3 columns, and rule number 2 also meet up at here at the table name service V1. On that table, single value employee number have multiple value of organization code, but this table doesn't meet up the rule number 3. Hence, this table has no multi-valued dependency and is proof for an F-based table. Next, I'm going to pass my presentation to Vicky.
Next is denormalization. First of all, we have to understand the normalization process. Normalization process is split up a big large table into a small tables. So we can understand the denormalization process very easily, because denormalization process is opposite or drawback of normalization process. Denormalization is a technique to merge all the small tables into a single and big table. This method allows us to add redundant data and anomalies into a normalized database to alleviate issues with database queries that merge data from several tables into a single table. The disadvantages of unnormalized tables is data updates are less efficient because tables are larger. Before this, we have learned about update anomaly, right? Update anomaly means we cannot update a single value in a big database, because we have to add every value in a row, but we cannot add a single value in a database. And next is indexing is more cumbersome. Next is no simple strategies for creating virtual tables known as views. Next is differences between normalization and denormalization. In a simple word is normalization is split up a big table into small tables, and denormalization is a merge all the small tables into a single big table. The functionality of normalization is removes redundant information and improves data change speeds. And the functionality of denormalization is combines multiple information into one unit and improves data retrieval speeds. Focus of normalization is cleaning up the database to remove redundancies. And the focus of denormalization is redundancies introduced for faster query execution. For your information, we can do query in a very fast time, in a quick way, when the table in a single table, whatever it is in a big scale, because it is very easy to search data in a big table also. When we have many joins, we can't do query in a simple way. Okay, next is memory. Memory of normalization is optimized and improve general performance, and the memory of denormalization is memory inefficiency due to redundancies. Redundancies is duplications of data. Integrity of normalization is removal of database anomalies improves database integrity, but integrity of denormalization is no maintained data integrity because database anomalies are present. Thank you.
Okay, so guys, you are writing down anything after this, right? Naufal, is that all? Is this all the groups?
So we separate. No, actually, there's chapter 6, and there's also three more groups.
3 more to go?
Yes. You still want to continue, or?
Honestly speaking, I can't hear you properly. So now, how many groups are left? I mean,
There are 3 groups left for one more chapter, chapter 6.
3 more groups for one more chapter.
Yes.
Okay, I think this one for the 3 groups we can carry it on next Monday, because I think now everyone seems to be, I don't want to say bored, but many of us are feeling sleepy because of some of you guys are reading from the slides. So I think it will be better if we refresh, and we will carry on with the 3 groups on Monday, and we'll discuss about the assignment by then. How about that?
All right.
Okay, so just let me know which group presented. If you can send it to me as Excel file, and I want all your names. And at the same time, the other group, inshallah, on Monday we will carry on with you, and you will do the first part of the class for presenting your doing your presentation, and for the other part, I'll be discussing about the remaining chapter and about the assignment. Okay. Okay.
Sir, wait.
Yes.
Do you want us to write down names?
I want you to give me the names of all the group members and each group who presented, and I want them to share with me some of their slide, because I saw some of you did not only use my slide, they added more content. So if you can all send me your material, send me your names in Excel file, and for the other group we will discuss on Monday. No need for you, Nofal, to give me these details. Everyone who presented, just send me one message to my email with your presentation slide, with your group member names, and for the others, inshallah, on Monday we'll discuss.
Okay.
Okay, guys?
Okay.
Okay, Doctor.
Okay, that will be all for today. Thank you so much. And inshallah, we'll see you after like 3 days, inshallah.
Okay.
Thank you, Doctor.
Thank you.
Yeah.
Thank you, Doctor.
Thank you, Doctor. Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome.